electric train.
What is it? How does it work? I don't know about it.
We have been researching for a big while. And if you want to know more about it, follow us.
Okay.
Hi! So we're going to show you about our apparatus that we use. So the first one is bare copper wire with 1 millimeter diameter. What's next?
3H PVC pipe.
And alkali battery.
And we use a drill to make a car.
So the last one is
The last important, neodymium magnet.
How was it?
I love it! Oh my god!
Oh, you really are!
Yes! How does it work? I don't know about it.
Now we're going to talk about the mechanism. Why does the train work? I have a battery and 2 neodymium magnetic. I put one magnetic on the positive side and I put the other one on the negative side. Then I will let the magnetic touch the coil. This way, the electron from the battery will come flow through the coil. That make current.
When there is current in the wire, it induces the magnetic field. In this direction, from the equation F equals to current times with the length of the wire crossed with the magnetic field. So our battery will be pushed by the magnetic force in this direction.
So when you got this and you put this into the coil, be careful with the sparks, but it's alright, it's not that much. So your magnets have to be in the right orientation or else the magnetic force will be in the opposite direction to the magnetic field.
We move back to the basic electric field concept. The positive charge will flow in the same direction of the field, and the negative charge will flow in the opposite direction to the field. And the magnetic field is very similar. The north magnetic pole will be pushed in the one direction, and the south pole will be pushed in the other direction. If the magnetic field is not the same all over, it's called non-uniform magnetic field. You might feel a slightly bigger push on the north pole than on the south pole of the magnet. And that's what's actually happening here. The magnetic field is created by the current is strongest in the middle, and then it spreads out and it becomes weaker at the end. You can make your train just a little bit quite faster than it used to be. So what you've got to do is like, if you've got these two poles facing each other and two nodes in the middle, they're feeling stronger push than the south on the outside, and if that push is in the right direction, it's gonna shoot straight through like so. Cool, blimey!
Now I know the mechanism of it and I apply it in the model. Yes, it is.
For the applications, at the very first time that we've seen this, we thought that what about making train from this concept? We have learned that we can make an electric train above two coils attached to each other like this. We found that it's slower than running in the tunnel. But if we continue this kind of prototype to make a huge one for the real transportation, we don't need to coil the big diameter tunnel up. Instead, we coil the smaller one, but like 10 or 20 coils. And we can reduce the risk of the sparks danger, the there can occur a huge accident to our passengers or the thing inside the train. The driving force of the train is from the electricity, like from the electric energy. There's no carbon dioxide producing while the train is running, so I can say it's quite cleaner than we used oil to be the fuel.